In today's lesson, we are going to continue to look at how to collect primary data. And in this case, we're going to be looking at sampling the population. So we've talked about in previous lessons that in order to get a good representation of the population, you may have to use a sample. And there are benefits to using a sample, mainly being that it's cost effective to use a smaller group, and it's more easier or it's more easily managed, again, when you're dealing with a smaller group of people compared to the general population. So again, for example, if we're looking at, say, Canada, we're not going to sample or we're not going to ask every person in Canada. It'd just be too difficult or too time consuming. So we might take a smaller group, or maybe we take a sample from that population. So we're going to look at different ways we can create those samples. Now, as a warm-up, there is an interactive in the course content. It's called kind of like a freestyle sampling or a warm-up. So if you go to the course content, you should see something that looks like this. So basically, we have a population of 100 people above, and we want to go and basically select 20 people into the sample area. So all you have to do is just drag and drop people, something like that. And you want to create or drag 20 people into this group. So you can look at what I'm doing. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there, I've selected 20 people. Hopefully you would do something similar. And then I want you to ask yourself, how did you choose those 20 people? What methods did you use? Did you just randomly select? Was there another method behind your selection? I just want you to take a second and think about what you did. For me, I just randomly picked. I just was going through, grabbing 20 people off the screen and putting them into the sample area, or 20 people out of the population and putting them into the sample area. It had no rhyme or reason to it. There was no kind of order to it. I was just picking people that I saw. So that idea is a bit about one of the ways we can sample. So sampling techniques, for a study to be valid, the conclusions need to represent what or who they claim to represent. So again, we've talked about that before in terms of a study being valid. It needs to represent who they claim to represent, or the conclusions need to represent. If they don't, then it would not be considered valid. The sample needs to represent the population. So again, the sample is a smaller group and it represents the population. Now, how we sample can be categorized into random, random from groups, and non-random. We're going to be kind of looking at the two overall categories of it either being random or non-random. If you use a random sampling technique, then each member of the population has an equal chance of being selected. So if it's a random technique, everyone has an equal chance. If it's non-random, each member does not have the same probability of being chosen. So not everyone has the same chance of being chosen. So those are the differences between a random and a non-random sample or sampling technique. So we're going to go through and list some of the techniques. Here we have a simple random sample. So a simple random sample is a percentage of the population is chosen at random. So you could say, similar to what I did in the investigation or that warm-up, I just randomly selected people. Everyone had an equal chance. It was just a matter of who I picked. If you wanted to put more of a technique behind it, maybe you use a random number generator, and whoever's at that number is who gets chosen. For a systematic random sample, the population is sampled from an ordered list, which chooses individuals at regular intervals. So this would be, if I order them, just put them in order. Maybe it's by age, or maybe it's by alphabetically, something like that, by height. And I select every fifth individual from a group of 20 to create a sample of I select every fifth individual from a group of 100 to create a sample of 20. So this might be similar to, if you remember, into gym class where they had you line up, and then you did like 1, 2, 3, 4, 1, 2, 3, 4, and so on. That's almost kind of like a random sample or a systematic random sample. Random sampling from groups, we have stratified random sampling. This is where the population is divided into groups based on certain characteristics, and then the same percentage is taken from each group. So for example, you might think of dividing the school up by grade and taking 10% of 10% of each group, so 10% of each grade. Cluster random sample, population is divided into groups that generally have the same size, and then a certain number of groups are chosen. And every individual of that group are chosen for the sample. So it might be something like we take the school, we divide it into classrooms, and we select 5 classrooms. And we sample or we interview or we survey every student in those classes that we chose. So that's an idea of cluster random sampling. Multi-stage random sample, the population is divided into a hierarchy and a random sample is chosen from each level. So say maybe to sample a city, you may choose some subdivisions or buildings, then randomly choose streets or floors, then randomly choose some addresses. It could be we take the school population, we divide it in half, divide it in half again, and divide it in half again, and that last half is who we're sampling. So as long as there's stages to it. Non-random sample. A non-random sample, we have voluntary sampling, and here is where participants choose whether or not they will participate. So this might be something like the YouTube ads or the YouTube surveys that you see popping up before videos. Right? It might be a survey that pops up. You don't have to answer it. You can just click next or skip, and that's an example of a voluntary sample because again, the participants choose whether or not they want to participate. Convenience sample, individuals are chosen from a population who are easy to access. So if I want to learn about teenagers, I might ask students in the school or students in my class. It's easy to access. Say maybe a sports store wants to survey or learn more about the buying habits of people, so they ask whoever walks into the store. And so that's an idea of a convenience sample. And it might be similar to a voluntary sample, because again, if you're asking someone, or it could be the idea that maybe it's not voluntary and it's mandatory, and that kind of eliminates one of them. So you can go back, there is another interactive on the website that does kind of go through and show you how to sample or the different sampling techniques. So if we go back and take a look at it, we still have 100 people. Some of them are a little bit cut off. So random sample. So random sample says click the button to generate a random number, drag the image or person that corresponds to that number in the sample area. So 99 was my number. So I'm going to grab person 91, 66. Grab that person. So same idea, right? So everyone has an equal chance, and we're going through there. So there are other interactives going on there. I do recommend that you go take a look at it to get more of a visual understanding of how these sampling techniques work. There is some bias in sampling depending on which method you choose. And again, we've talked about these before. In sampling bias, a sample is biased when it does not represent the population. So again, depending on what we're looking at, if our sample does not represent the population, there is sampling bias there. Because there's some bias in the methods of which we sampled that doesn't accurately represent the population. Non-response bias is similar. It's when the sample does not represent the population because a portion of the population is missing. So we are missing a portion of the population or a group of people from the population. So again, it makes it not valid because it doesn't represent the population as a whole. So what I want you to do as an example is go through and think about how each of the following sampling techniques can be biased. So we talked about the two examples of bias. Either the population isn't being represented or part of the population is missing. So I want you to take a second and go through each type of sampling technique and think about how they might be biased. Then I want you to think about which sampling techniques have the potential to limit the most bias or the least bias. Why might they still be useful? Right, so why might it be useful to use some of these techniques even if there is a lot of bias in there? Right, so again, kind of open-ended, but take a second to try to think about it, because again, the main concept from this lesson is how the different types of techniques. Now, in class, we are going to go through another type of demonstration or visualization, and again, this is something that you can also try at home with a few accessories. So the interactive or the kind of visualization that we're going to do is looking at sampling using Skittles. So we are basically, you can do this if you have a bag of Skittles. You just need to open up the bag, and we're going to look at the various ways to sample. So for a census, we didn't really mention this as a sampling technique because it's not really creating a sample. The census would be the entire population. So if you took the bag of Skittles and poured them all onto your desk and recorded how many of each color there were, that would be an example of a census because you're looking at the entire population. You're not taking a sample or taking a smaller group, you're looking at all of the individuals. Now that is a type of survey technique, but it's not really considered a sampling technique because you're not taking a sample from the population. Random sampling. So from your bag of Skittles, randomly select 15 of them and record how many of each color you get. Right, so that's an example of random sampling. Each one has an equally likely chance of being selected. You pick 15 of them. Systematic random sampling. I want you to put all the Skittles in a straight line and select every third Skittle. Record the number of each color. So again, you've ordered them and you're selecting every other or every third one in this case. Now this part here, the every third, that can change depending on either how many individuals you want in the sample or just up to you. You can choose every other, every fifth, every 10th. Again, it would most likely vary depending on how many individuals you need to choose or how large you want the sample. Stratified random sampling. So sort your Skittles by color, and then from each color choose 25% or 1/4 of each color, and then record the number of each color that you have. So again, you're breaking it up into groups and then taking a proportion or the equal or same proportion from each group, or same percentage, sorry. Cluster random sampling. Sort your Skittles by color. And once you sort them by color, choose all the Skittles of 2 colors. Record the number for each color. So you will only have numbers for 2 colors, everything else will be 0. And you can probably kind of see how there might be some bias in this type of sampling. Multi-stage sampling. So randomly choose half of your Skittle population. Then from there, randomly choose half of that group. And then finally, choose half of the group from the second round. And that group that you chose from the second round, this is your multi-stage group. From that group, record the number of each color. Voluntary sampling. Ask the Skittles who would like to participate in your study. Record the color of those that respond. So again, you can kind of see how there might be some bias in this example as well. Convenience sampling. Pick the 10 Skittles that are closest to you. Record the number of each color. So again, you can see how there might be some bias there. So this kind of demonstration was to kind of give you a visual representation of how these sampling techniques work. Again, you could use the interactive in the course content, or if you prefer a bag of Skittles, I recommend you can try this example or this visualization as well. But again, the main idea is to understand the different types of sampling techniques out there and how there might be some bias or inherent bias in the types that you choose.